Okay, right. So we have 2 and 3 force members. This is continuing of our chapter in it is actually in chapter 4. Okay, 2 force members when force are applied at only 2 points on a member. 2 points. The member is called a 2 force member. Okay, 2 points. 2 force member. To satisfy force equilibrium, equilibrium is F equals to 0, moment equals to 0. Both forces A and B, like in the figure, should equal in magnitude and opposite direction. So, to consider it, in equilibrium, the same magnitude is you need to the magnitude of the magnitude of the forces must be equal and it must be in opposite direction. Okay, so that in stable. So dengan kata lain, if you have x 20 Newton, okay, force the x to the x direction is 20 Newton, and you need to have 20 Newton to the left to make it balance of equilibrium. Okay. To satisfy moment equilibrium, okay, so refer figure B, FA equals to F, FB equals to F. So you need to have same magnitude. This is the same magnitude. And you need to have the opposite direction of forces. To satisfy moment equilibrium, moment is equals to 0. Both forces FA and FB should equal in line of action. So, collinear. What happens if you have if the line is not satisfied? Okay, let's say you have this is the force. This is the same magnitude, but not in one line, not collinear. Okay, so if you have this type of forces, you will have couple moment. So we don't want that. So for equilibrium, it must be 0. So for two force members, it is very easy. It must be collinear. But what if there are 3 force members? Okay, 3 force members. When members subjected to 3 forces, it is called 3 force members. So 3 forces. Moment equilibrium. Summation of moment is equal to 0. It must be 0 so that your body, your structure is not moving because of the moment. Can be satisfied only if the 3 forces form a concurrent or parallel force system. Okay. To be clear, see the F1, F2, F3 in figure A and figure B. If the line of action for figure A, okay, look at this figure A. For F1, F2 intersect at point O. Okay, intersect at point O. The line of action F3, if the line of action F1 and F2 intersect at point O, the line of action F3 also should pass through point O. So F1, F2, F3 must pass the point O. Okay, so if you have point O and it is the force react on the line, okay, it is the action of the force is on the line, so you will have no moment. Moment is equals to 0. Okay. Next, if the three forces are parallel, the point of intersection O will infinity. Okay? No intersection, no point, no intersection, no concurrent, no point of intersect. Okay, so this is what you want to know, what you want to do, because the summation of moment must equals to 0. Okay. Example. Look at the example. So, sorry, excuse me. So, look at the example. So, dia akan lagi susah dan susah lah. The lever ABC is spin supported. The keyword is spin supported. Okay, A, and connected to short link BD. So we have short link BD. Okay. If the weight of the members are negligible, what does this mean? Negligible. Negligible. No. Not included in the system. Determine the force of the pin on the lever at A. So it is pin. So at A, it is pin. So you must have X and Y. Okay. So let's have a look how to solve the equation. You have two things you need to consider. The consideration is concurrent or parallel. There are two things. For this example, it is in concurrent. Concurrent means intersect. Okay. The first thing is free body diagram. Free body diagram. So you have 400 Newton forces act on lever ABC and link BD. Okay. So the first one is free body diagram. BD, we have two structure, two body. Okay, two structure, two body. The first one is this one. Okay, the second one is this one. So what happened? This is pin, this is pin. So we have that one. Okay, and BD. So we look at our BD. We have 0. Sebut 0. We have 0.2 and 0.2 meter. Okay, so this point and this point will have equal magnitude with opposite direction and must be collinear. What is the theta? What is the theta? Okay, 0.2, 0.2. This is square. So the theta is 45 degrees. Okay, so 45 degrees. Okay. BD is a two-force member, so the resultant forces at pins B and D must be equal, opposite, and collinear. Okay? I've shown it in the previous slide. Lever ABC is a three-force member. So to satisfy moment, the three non-parallel forces must be concurrent at O. Where is O? Okay, kita tak tahu O kat mana. Alright, so after you have your body, okay, you have your body, and this is from the BD body, okay, link BD, okay, and then you have your line, and you have 400 Newton in your line. Okay, because of BD is acting 45 degree, so you have so this is BD in 45 degree, and this is also 45 degree. So if you have 45 degree and you have the length of link is 0.5, so the upper side is 0.5 meter. Okay? Because they didn't give you an intersect point O, so you need to draw your intersect. Okay, so from that you have your intersection of point O is 0.5 meter from C. Okay, so this is the triangle with 45 degree. Okay, okay. Next we have body. We have FBD. We have pin FA. So we have FA and FA will intersect at point O. Why? Why? Because it is equilibrium, so you must have moment equals to 0. One point to intersect, it will give moment equals to 0. Okay, as simple as that. Okay, so from this one, we have this one. So we want to know our theta. Okay, so we want to know our theta. Tangent theta is equals to tangent -1. This is 0.7. And this is 0.4 equals to 60.3 degrees. So theta sama dengan 60.3. Okay. Okay. Untuk apa? Untuk you break fx dan juga fy. So you need a theta. So that we can solve our equation of equilibrium in x and y direction. Fx positive equals to 0. Positive summation of fx equals to 0. So you can have so you have fa cosine 60.3. Okay, so for x, so in x, you have fa in x direction. So this is fa cos 60.3 degree. Okay, and then you have another x. This one x f b in x direction. It is in a negative x direction, so it is minus fb cosine 45 degree. And the last one, you have positive 400 Newton in x direction equals to 0. Okay, the you need to write how to write this kind of problems. Okay, the first one, you need to write this one. Okay, and then you you need to write your summation of fx. So the summation of fx is this one. Okay, so equals to 0. So this one equals to 0. You don't have to write your positive fx again. No, you don't have to do that. Okay, so write the summation of fx so that it is considered in your equation. Okay, so that is how you write. It is different from the previous chapter, which is we want to know fx in x direction. So we want the results. But in this chapter, we know that fx equals to 0. Okay, so what you need to do is you need to write your fx equals to 0. Right. So then you can finish your equation. Okay, it can have in unknowns. So two equations maximum is two unknowns to solve. Okay, two unknowns to solve. So 0.495 minus 0.707 FB plus 400 Newton equals to 0. 0.4 minus FB equals to negative 400. Okay, then FA equals to negative 400 plus 0.07 FB divided by 0.495. So we have that FA is equals to negative 808. This is actually 808.081 plus 1.428 FB. So this is equation number 1. And then Fy equals to 0. So you have your Fy. So this is Fy, Fa in y direction. And you have Fb in y direction and no other equation, no other forces that act on our body in y direction. So Fa sine 60 degree is plus minus Fb sine 45 degree equals to 0. So 0.869 Fa minus 0.707 equals to 0. So this is equation 2. Okay, so this is equation 2, and then equation 1 into equation 2. So you need to solve this one. Okay, Fa, the whole A put inside here. Okay. So you will have 0.869 times 0.808081 plus 1.28 FB, then minus 0.70 equals to 0. So you can solve it negative plus negative equals to 0, and then F equals to 0.2, FB equals to Newton, it is 1.31 kilometer. Okay, so this is FB, this is FB. So FB. Okay, so please just you need to solve your equation. Right. So for FA is equals to this one. Okay, equation 1. FA is equals to negative 808.081 plus 1.2 FB. So FB is equals to, ni dapat jawapan. Okay, from previous calculation, and then you can solve your equation number 1 plus masukkan FB, ni FB, okay? And then you can solve plus FA is equals to 1070 equals to, so you got your FA equals to 1.071 kilonewton and FB equals to 1.316 kilonewton. Okay. All right. So that is examples if you have concurrent intersection. Okay, you have intersection at O. But soalan ni jarang-jarang keluar lah intersection, tapi tak mustahil dia boleh keluar. Tapi normally kita ada yang parallel. So that's why from previous slide, parallel is rare. Next, we have two body, A, B, and we have link BC. The overhanging beam is supported by a pin at A and the two force strut BC. So pin and strut determine the horizontal and vertical components of reaction at A and the reaction at B. So dia nak tahu A dan B. So you have first one, what you need to do. So you have 600 Newton, 800 Newton, 900 Newton meter. So 3 forces given. So untuk PC, okay. So kalau kita ada load, kalau logik lah, kalau salah dia adalah just your direction. So for the free body diagram, okay, for the free body diagram, you have this one, and you have FBC, pin at A, pin is AX, AY. And then you have this type of force. Okay. So how to draw your free body diagram? This is the red one. FBD is red one. So you have this one, 600, 800, and 900. Okay. So I draw the free body diagram and label all the forces. So you draw your free body diagram and you draw your FBC. So look, AX and AY. It is just the direction. Okay. So from the figure, we have AX, we have AY, okay, pin, and we have FBC for the strut above BC, and then we have 600, 800, and 900 Newton meter. Okay, so this is your free body diagram. How did you get this one? Okay, this is from here, the triangle. 1.5, 2. Okay, so from the proportion, you can use that one, 3, 4, 5. Okay, so this one is 2.5. Okay, kalau calculator, 1.5 square plus 2 square. Square root 2.5. So boleh gunakan in your, kat sini, this one, your force. So for x direction, you can use 4/5 FBC, or also you can use 2/2.5 FBC. Okay, it's the same, boleh gunakan. And for y direction, 3/5 FBC ataupun 1.5/2.5 FBC. Okay, so this is where it comes from, the triangle. Ataupun you boleh guna, you cari this one. Okay, 1.5, 2.5, sorry, 2. This one is 2.5. You boleh juga cari theta, tak ada masalah, sama. Theta is equals to tangent -1 2/1.5. So you got your theta in degree. So you can use your x and y direction in degree. Tak ada masalah. Okay, next you draw your free body diagram, and then you write your equation of equilibrium. So this is the third one, free body diagram, next equation of equilibrium. Okay, so untuk moment, for the moment, kalau kita boleh cari titik yang paling banyak force, titik yang paling banyak forces. So titik tu mesti paling banyak forces lalu. So Fx lalu kat sini, Fy lalu kat sini, Fy, Fx, so dia paling banyak. Okay, so dalam y, kenapa kita nak cari yang paling banyak? To eliminate it in the equation. Okay, to eliminate unknowns in the equation. Okay, so if you have okay, so for now, sigma moment counterclockwise at point A is equals to 0. So you need to draw your, you need to write your equation. FBC, okay, FBC 3/5. So this is the process times distance. So this is F. This is distance. Counterclockwise positive, so this is positive. And then you have 600 Newton, clockwise direction, negative, 600 times distance. 800 clockwise direction, fixed at A, F distance is 1 plus 1 plus 2, 4. Minus clockwise direction, minus 900 equals to 0. So, ini moment diberikan. Okay, so we can solve our FBC is equals to 3.92 kilonewton. Okay, this is the answer. And then you need to solve, you need to write your X equation and also Y equation, and then you can solve your AX and AY. So for this one, AX is positive, AY is positive. So if you draw your AX that way, AY that way, the answer will be negative 3.13. So to do that, 3.13 kilonewton, positive in X, negative direction. Same with the AY. The answer will be negative 950 Newton. So it is equal to 950 Newton to the direction. Okay. It is just the opposite direction of your assumption in the early stage. Okay, so you can solve your equation. All right. So for 2 force member, 3 force member, macam ni lah. Kita kena buat free body diagram. Okay, the first one, free body diagram. And then you need to show your force, Fx, Fy, moment, and also force of the support. Okay, force reaction at your support. Okay, so kita tengok lagi example. Okay, example. Kalau ada apa-apa tak faham boleh tanya. Okay. A skeletal diagram of a hand holding a load is shown in the upper figure. If the load and the forearm have masses of 2 kg and 1.2 kg times 9.81 equals to Newton times 9.81 equals to Newton. So if the load, so this is a load, this is forearm. Okay, so G1, G2 and G1. So that is the center of gravity. Respectively, and their centers of mass are located G1 and G2. So if they give the center of gravity, so the load must follow the center of gravity. Okay, G1 and G2. So G1 is 2 times 9.81 equals to 19.62. 1.2 times 9.81 equals to 11.77 Newton. Okay, so this is 19.62 Newton, and this is 11.77 Newton. Determine the force developed in the bicep CD. Okay, kita ada CD. And the horizontal and vertical components of reaction at the elbow joint B. So, ni kita ada okay, joint B. So, ni lah. This is our free body diagram. The forearm supporting system can be modeled as the structure system shown in the lower figure. So, this is the free body diagram. And we have our distance, and we have our G, 19.62, so 11.77. Then you have your FCD. Then you have your pin. Okay. So itulah gambar aja untuk free body diagram. Okay. This one. In case free body diagram, force, reaction and support, external forces, and you can then write your equation of equilibrium. Okay, draw the free body diagram, resolve all the forces into x and y components, label the forces and distance. So, ni theta ada 75 degree. So, from that, we have 19.62, 11.772, and we have FCD, BX, and BY. So kita tak tahu yang tu. Okay. Alright. So we need to write the equation. So the first equation is moment positive for counterclockwise at point B. So point B. So B ada BX ada BY. Okay. So counterclockwise positive, we have the first one 19.62 times 19.62 F times D. D is 100 plus 135 plus 65 millimeter. And then we have 11.772 times from the point. Okay, the distance from point B 135 plus 65 millimeter, and FCD sine 75 degree. Okay, times 65 millimeter. FCD is negative because it is clockwise when it fixed at B. So we can solve our FCD. Okay, so satu je pun boleh ubah unknowns, so we can solve our FCD. Boleh ya? Okay, then for Fx and also Fy, then for Fy, Fy kita ada Y, FCD sine 75 ni Y and then BY. So kita ada 4 untuk Y. Okay, for Y direction, the first one FCD sine 75 positive and the others is in negative direction. So this one positive and then 19.62 negative, 11.772 negative minus BY negative. So BY is equals to 95 Newton. And then for Fx, you have this one, FCD cosine 75 minus Bx. So this is minus Bx plus cos 75. Then you can solve your Bx. So you get your answer Bx, By, FCD. So dapat Next, examples. Okay, the jeep frame is supported by a pin at C. So C ni dekat point C tu dua lah, AX, AY. Oh, sorry, AX pula point C. CX, CY. Okay, itulah CX and CY. And road B. Okay, pin at C and road AB. So ni ada road lah. If the load has a mass, ni load 2 megagram, Mega is 10 to the power of 6. With its center of mass located at G. So sini lah. 2 megagram times 9.81. Determine the horizontal and vertical components of reaction at pin C and the force developed in rod AB. So dia nak tahu yang ni dan juga FAB. When X equals to 5 meters. So masukkan je lah. Okay. Free body diagram. Number 1. So for the free body diagram, okay, so kita ada 3.2 ni diberikan ni kena tolak ni. Okay, so mata tu kena hati-hati. So 3.2 tolak line ni is 3. So segitiga, the triangle is 3, 4, and this is 5. So kat sini 3, 4, 5. Okay. Right. So from that we have a CX and CY, and then we have FAB acting for the triangle 3, 4, 5, and we have the 2 megagram. Okay, 2 megagram, and this one, please remember, tu saja je buat 2 megagram. Sebab nanti you will times 2 times 10 to the power of 6 times 9.81 equals to Newton. Okay? Salah. Yang biasa yang kita buat bukan biasa. Kita punya cara kiraan adalah M times G. W equals to M times G. M in kilogram. Okay. 10 kilo sebelum ni. Okay, ni. Okay. This is how you calculate your weight. W is equals to mg. M in kilogram. So jangan silap. So this is kg. Please remember. Okay. And then apa lagi yang ada? Kita ada load kita ada pin CX, CY, load B, load D, kat D, and kita ada F, AB. Alright, so itu adalah the free body diagram. So when you draw your free body diagram and your reaction and support, you need to write your equation of equilibrium. Okay. So for the equation of equilibrium, you nampak, okay, sebelum ni apa yang kita belajar Fx, Fy, moment. Tapi dalam examples, kebanyakannya adalah buat daripada bawah ke atas. Moment, lepas tu Y, lepas tu X. So, kena biasakanlah. Sebenarnya nak cari apa yang soalan nak. Okay? Tapi kebanyakannya begitulah cara dia untuk dapat, dekat sini boleh dapat satu anus dah boleh selesai. And then you can use the unknowns, the value in the Y and also X. Okay, so our equation of equilibrium, moment is equals to 0 at C. Okay, so C here. Moment is equals to 0 at C. So Cx and Cy is absolute, and this one means you have your moment. Okay, so the moment at B is actually you have Bx and you FAB in x direction, and you have FAB in y direction. Yeah. Yeah. So FBX must be calculated in your equation for moment because they are given 0.2 mm of distance. Okay, right. So for moment yang paling jauh, the first one is negative 19,620 Newton, negative, because it is clockwise when you fix at your C times 5 meter. Okay, and then you have FAB in x direction. So in x direction, distance is 0.2. It is in counterclockwise direction, so it is positive. Then you have FAB in y direction, positive because of counterclockwise direction. And then settle this, and then dah habis lah. Okay, so ini dah settle distance 4 meter. Okay, you can solve your FAB and get your answer. Next, FY. So for FY, we have CXY. We have FAB in X direction. Dah. So 2X untuk Y, CY, FABY, and also we have our load. So 3. CY in a positive direction, negative direction of the load, and we have FAB. So masukkan FAB dalam ni, we can solve your CY. See, CY is negative. So because of your assumption, that CY is upward, but the answer is negative. So actually CY is positive downwards. Okay, positive downwards. Downwards je lah. Okay. Alright. So ini downwards ataupun you can use your arrow. You need to draw that if it is negative so that you know your answer is the opposite direction. Okay. So next FX, you have CX and you have FABX. So CX, FABX, you can solve FAB to get your CX. So itu sajalah untuk equation for 2 force member, 3 force member. Okay. So problem example lain you boleh tengok satu dah diberikan. Okay. So yang ini dia punya roller at B, so dia punya free body diagram yang ni. So itu adalah dia punya body. So you need to use pin at A. So dekat A ni ada pin, dekat B ni ada force A, X, A, Y. B ada force, F ada force. So kena pastikan dan kena buat free body diagram. Okay. So, free body diagram yang ini diberikan theta 60. So dia sengitkan sikit je. Sengitkan sikit dan nanti akan berubah lah. You ada Fx, you ada Fy dan seterusnya. Okay. So, ada juga penyelesaian equation of equilibrium. And then problem 4 to 1. So tadi satu saya tak terangkan. Ini nombor 2. So tengok balik. Dah diberikan. So you have your structure. The whole component is structure. And then you need to draw your free body diagram. So free body diagram. And you have your roller normal to the structure. Okay. And then you can solve your, you can write your equation of equilibrium. Then you can solve your equation. And then, okay, so this one, outriggers problem 4.17. Ini nombor 3. Sama juga diberikan kita ada load, untuk ni dan kita ada load untuk ni. Okay. So, bila ada center of gravity, so ada load 5 megagram, 0.6 megagram, 3 megagram. So, untuk load, W is equals to mg, M is in kilogram. Okay, so this one is actually, this is 4.5 and this is 5. Tapi dia jarakkan lah ke atas. This one. Okay, untuk tulis. Tapi actually, this is the triangle. Okay. 4.5, 9.5. Okay. So, sorry. The triangle is this one, X. And this is 4.5. This is 5. So this is X. Okay, so this is reflects to this. Macam mana nak cari? Okay. So, boleh tengok solution untuk free body diagram dan boleh selesaikan equation. And finally, ada lagi dua sini. Apa lah. Okay, you have this structure. So structure tu kena faham pin and bolt. So this is your components. Okay, this is pin at C, and this is the strut bar. Okay, and then you have another force. This one, external forces. So selesaikan juga dan buat equations of equilibrium and you can solve the equation. Alright. So ada apa-apa soalan sebelum saya akhiri? Okay. Sebab apa saya habis awal? Sebabnya Okey, yang semalam saya dah upload video semalam. I have upload video semalam dalam week 4, chapter 4. And also I have upload also tutorial 3 this morning. Okay, so inilah soalan untuk this chapter. Then you need to solve your jawapan. Ya, tak apa, nanti saya akan masukkan yang ada jawapan. Saya masukkan jawapan dia. Okay. Tapi ini soalan dia, boleh buat dan siapkan. So next week kita akan masuk pada structural analysis and also we will discuss our tutorial. Okay, itu sahaja. Terima kasih. Saya akan ambil attendance. So attendance 43 orang. Ada siapa-siapa tak masuk lagi dalam grup baru? Siapa yang belum masuk? Tutorial answer yang mana? Kenapa belum masuk? Nanti PM saya. Siapa yang belum masuk grup baru, nanti PM saya. Sebab itulah memang ada kekurangan 2 orang lagi. So ada mungkin seorang lagi untuk bisa carilah siapa. Okay. Okay, nanti PM. Kenapa tak masuk? Saya bagi link semalam. Ada ke tak ada depan komputer? Tutorial 3 jawapan bila boleh dapat. Saya akan upload sekejap lagi. Saya masukkan jawapan dan saya upload benda yang sama, tapi saya tambah jawapan. Okey? Kejap je lagi soalan. Okey, kalau tak ada apa-apa, itu saja untuk hari ini. Class dismissed and please take care of yourself, of your family. Kalau ada apa-apa boleh tanya dalam group. Itu saja. Terima kasih. Bye. We can leave meeting room.